Hello, I'm Brother Dougie. I saw a very informative YouTube video by Veritasium about how no one has figured out how to measure the speed of light in a single direction. Great video, very informative. Now, when I figured out the true nature of time, I realized that two particles fired in the same direction at the same time at the same velocity would have the same wave function. I then found out that scientists already knew that, but couldn't find any explanation as to why that is. But I already knew that. So anyway, here's how you can use that particular factoid to measure the speed of light in a single direction. Imagine a single emitter firing a particle towards a detector. That particle will arrive at the detector at a certain time and in a certain location according to its particular wave function. Those two pieces of data, arrival time and location, create a data point. Now imagine a second emitter firing a single particle at a second detector at the same time and velocity, but in a different direction. That creates a second data point, based on that particle's particular wave function. Now imagine 100 emitters, each firing a single particle at 100 different detectors at the same time and velocity, but in 100 different directions, creating 100 different data points. Concatenating all those data points creates a fingerprint for that particular moment in the history of the universe. I don't know if it would require more or less than 100 different data points, but if the data set is sufficiently detailed, it should only occur once in the history of the universe, which creates a universal clock. Now, since two particles fired in the same direction at the same time at the same velocity would have the same wave function, if you set up an identical experiment, say 1 kilometer away, it should generate the same fingerprints at the same time as the original experiment. So if you fired a particle from the original experiment, noting the fingerprint that occurred at that moment, once the particle arrives at the second experiment, you note the fingerprint that occurred at the arrival time. You send that fingerprint back to the original experiment. The original experiment looks that fingerprint up in its database because it saw it too. Now you have the time to travel and you know the distance, and from that you get the speed of light in a single direction. Now, if someone is educated enough to set this thing up, here's what you should notice. The speed of light is actually random, but within a very tight tolerance. But you should be able to predict the distribution of that randomness with the Schrodinger equation. This, of course, will require very accurate atomic clocks, but I heard somewhere they have atomic clocks that can measure the difference in the flow of time across a millimeter of space, so they should be able to manage it. Also, you'd have to fire those particles at a pretty decent clip. Again, I believe a doable thing. Now, here's what else you may notice. If you measure the speed of light accurately enough for long enough, you may notice that the very tight tolerance window of the speed of light is moving downwards, thus disproving the existence of dark energy by proving that the universe is not speeding up, but rather the flow of time is slowing down and taking the speed of light with it. Now, unless I miss my guess, once you collect a sufficient amount of data, have an artificial intelligence mine that data for patterns, and well, you may find a solution to the Fermi paradox. So, if anyone is educated enough to set this up, enjoy your Nobel Prize and happy sciencing. I'm Brother Dougie.